Hi everyone, this is Srikanth Yadav, working as Assistant Professor, Department of IT, VFST at Dmt U2 Video3. So in the series of data mining lecture series, till now we completed various data pre-processing techniques. In the previous session, we have seen a dimensional reduction approach under data reduction data pre-processing technique. Now in this session, we are going to see the second approach, that is called numerosity reduction. How the number of attributes are going to be reduced and unimportant attributes are going to be eliminated is going to be discussed in this numerosity reduction. Let's have a look on this slide. So here the numerosity reduction is mostly used to reduce the volume of the data. That means when we are having a vast or enormous amount of data, here we want to reduce the data by using the alternative approaches. That means representing smaller forms of data. So instead of taking the complete and large amount of data, better take reduced and smaller form of data so that we can get same results, or you can say better results also. So here in this data reduction, we are applying the numerosity reduction approach. So in this numerosity reduction approach, here we can apply a parametric method called regression approach. So in this regression approach, the dependency between the attributes and the values is going to be derived, and based on the rate of dependency, the consideration of data and reduced format of data can be observed clearly. Now let us see how this parametric method will apply on the data. Assume that the data fits some data model. That means let us assume we designed one data model, and how can we apply the data on that data model? So here we have to estimate the model by taking the parameters, and we have to store those best parameters in the training level are going to be used throughout the session. So here when we are able to identify the best parameters which are going to be derived or which will give better results are going to be considered, and the remaining parameters are going to be discarded. That means among the existing parameters, the best suitable parameters are going to be taken and applied on the data model. Now here in this process, the possible outliers are going to be eliminated. So in this parametric approach, we can apply a log linear method, which is used to obtain a value at a particular m-dimensional space. Here we can apply either 2-dimensional, 3-dimensional, we can go for up to m-dimensional in maximum. So in this m-dimensional maximum dimensionality space, as the product of appropriate marginal subspaces is going to be derived. That means comparison between all the attributes and the parameters are going to be observed, and best values are going to be taken in that m-dimensional space. And there are some alternative approaches which are not parametric models. So in this non-parametric methods, here we will not assume any predefined data model. That means randomly you can apply any one of the data model and we'll try to observe the results. And here under non-parametric approach, we can go for histogram, that is representing data values in the form of bars or bar charts, clustering, grouping of the elements based on the similarity and dissimilarity, and selection of the data based on the sampling approach. So using these non-parametric approaches also, we can reduce the form of the data under numerosity reduction. So in this numerosity reduction, either in parametric method or non-parametric method, we are not deleting the data. Here we are converting the form of the data, either by applying a parametric approach or non-parametric approach. Now under parametric data reduction, we can apply regression and log linear models. So in linear regression or multiple regression, we can deploy the data on m-dimensional space and we are going to derive the subspaces among the data values in a reduced format. So here we'll try to represent or lay out the data in the form of a straight line. So data modeled to fit in a straight line model. Often it will use the least square method, which is used to put the data on the straight line approach. If any value which may not fall on the straight line path, we can consider it as an outlier. And when it comes to multiple regression, we are going to apply more than one variable at the same time. That is, a response variable y is going to be modeled on a non-linear function, and we are going to derive a multi-dimensional feature vector. So when you compare this linear and multiple regression, in linear regression, the number of parameters that we are choosing is going to be limited. When it comes to log linear model, the data approximates are going to be used and are going to be derived by using discrete multidimensional probability distribution. That means in log linear method, probability distribution approaches are going to be applied in order to derive the best numerosity reduced data set. If we look at this diagram here, the regression analysis have been deployed in the form of a graph here. So in regression analysis, a collective name for techniques for the modeling and analysis of numerical data. So in regression analysis, we are focusing mostly on numerical data, which will consist of a values of a dependent variable here. Now those dependent variables, we can call it as a response variable or a measurement. Just have a look on this graph here. In this two-dimensional space, here we are trying to deploy all the values on a straight line. So here we are going to represent this line as y equal to x plus 1. So all the values of x and y are going to be substituted in this equation, and we are trying to get the values, and we are trying to observe all the values whether they are falling on straight line or not. If you look at carefully, these points which are closer to the straight line, some of the points which are far away from this straight line aspect. So here, when we want to eliminate the point which is having highest distance from the straight line, that can be used for the removal. That means this point can be is going to be reduced or removal in this regression analysis, and these points which are closer in nature are going to be considered for analysis. So in this aspect, we can try to reduce the attributes. So this is the way, and the parameters are estimated to give as a best fit of the data. So whichever values which are closer to the straight line which has been deployed in that linear regression will be taken as the best fit, and the values which are far away from the straight line we can call it as the worst fit. So here it depends on how we are going to categorize the values. The most commonly the best fit value is evaluated by using least square method. Here we are using an estimated approach or a measurement approach called least square approach to derive the data. So under log linear method, here what we are doing here, as we discussed earlier, the linear regression is going to be applied by using a straight line equation, that is y equal to wx plus b, or generally we will call y equal to mx plus c in a standard mathematical representation. Here we are taking the help of two coefficients which are called as regression coefficients, that is w and b are going to be used to specify or to measure the line estimation of the data. That means w and b are going to be used and our values are going to be supplied into the straight line equation, and we'll try to get the new value of y, and we'll observe where that y value will fall on that straight line. So this is the way we are going to identify the best fit of the model. When comes to multiple regression, here more than two variables, or you can say two regression coefficients here we are considering. That means at a time more than two dimensions are going to be taken into consideration to find out the best fit of the model. When comes to log linear approach, we are going to apply the discrete multidimensional probability estimates are going to be used. Here we can go for a binomial distribution or a Poisson distribution or any distribution technique which best suits in probabilistic approach, that is going to be applied on the log linear approach. And now under non-parametric approach, here we can go for a histogram. Now in this histogram, what we are trying to do? Here we are trying to divide all the values in the form of smaller portions, and these smaller portions we are calling it as a buckets. So divide the values based on some criteria. Let us assume we are having student marks which are falls in the range from 0 to 100 marks. So instead of deploying all the student marks in this range, divide the marks range. That means number of students who got marks 0 to 20 will deploy on 1 bar. Number of students who got marks between 21 to 40 will take 1 bucket or 1 group. Like this, the all values, let us say there are count of 60 students. Instead of drawing 60 lines on this graph, if we apply histogram, we can draw maximum only 6 bars or 6 lines. That is 0 to 21 group, 21 to 40 and 1 group. Like that we will have 81 to 100 is the last group. So this is the deployment of the values. Now, and how can we partition it? That means how can we form a bucket? So here we can go for an approach called equal width. That means every bucket will have equal range, like 0 to 20, 21 to 40 is the equal range. Every range is having maximum 20 values only. And equal frequency. In equal frequency, instead of taking that range, we want to deploy 20 values in 1 bar. That is the meaning here. So in equal width, every bucket will have equal size like this. Every bar width will be same. The height may differ. The height may differ. When it comes to equal frequency, here we want to take equal number of values in each and every bar. So this is the way of deploying or reducing the data under non-parametric approach. And the second approach is the clustering technique. In this clustering approach, partition data set into cluster based on similarity measure. That means by applying some standard similarity measuring techniques like Euclidean distance, Manhattan distance or cosine similarity, try to group the values. Values which are most similar features, group them. If any values which are dissimilar with other, let us make them in another group. That means all values with similar features will fall in one group, and remaining values with dissimilarity nature with that first group will fall in another group. Even though they are dissimilar with the first group, but they will have similarity in its group itself. Like when we want to divide the students based on gender, the male group and second one is the female group. That means we can form two groups. Like we want to divide the student based on the pass percentage, or I can say failure or passed. So all past candidates we can group. They will have the similarity. That means they all are passed. And failure candidates, they may have either 1 or 2 backlogs and they are having a similar feature. They are failed in examination. When we compare both, they will have a dissimilarity. But when we consider together, that means all the elements within the group, they will have a similar features. So here we are going to partition the data into clusters based on by calculating some similarity measures of the cluster. So here to find out the similarity of the set of values, we can go for centroid approach or diameter approach only. And next one is when we formed a cluster, based on the clustered value, the value can be smeared. And next one, when we are applying a hierarchical clustering and storing in multi-dimensional indexing, we can go for a data structure representation to store the data values. And next one, when we are applying clustering technique to find out the similarity, here we can choose what type of clustering we can apply and what is the features that we can derive using clustering approach. Okay. When it comes to the sampling, sampling is one of the alternative technique which we can use under non-parametric approach. Here we want to choose the sample value like sampling, obtain a small sample S to represent the whole data set N. That means here we are having a large data set, that means we are having 1 to 1000 records. Among these 1 to 1000 records, we are picking 50 records per analysis. That means out of 1000, we are picking 50 records. How can we pick those 50 records? That is another concept. That means whether we can pick randomly or we can pick repetitively. If we are repetitively picking the values, can we have same value that can be repeated more than one time? That is sampling with replacement, sampling without replacement. Those concepts we will see after this. But here we are focusing on, here sampling means we are taking a small sample from the large data set. If the large data set, let us assume it is N, from this N, we are trying to derive a small amount of samples. Now on this sample, we can apply our required analytical activity. Now what is an advantage of sampling? It allows a mining algorithm to run in complex, that is potentially we can go for a sublinearity based on the size of the data. That means if the results are not satisfactory, we can increase the sample size. Let us take 50 to 100, we can increase the sample size. And what is the key principle behind choosing a sample? Here, simple random sampling may have very poor performance when we present in the skewed data. That means when we pick randomly data set, the performance is not up to the mark. Now here we are going for an adaptive sampling approach, that is stratified sampling. Instead of selecting a random sampling, we will apply some mechanism that selection is also done in meaningful way, that is stratified sampling. Now here sampling may not reduce the database, it will reduce only processing time or IO accessing time. Now under sampling, that is selection of a sampling based on simple random sampling. There is an equal probability of selecting any particular item. We can select any value based on our interest. When it comes to sampling without replacement, that means once an object is selected, it is removed from the population. That means let us assume we selected first 50 records from the 1000 records. When we want to select it again, select from only from the remaining 950 only. That means once we selected a sample space, that let us say this is sample 1. When we are going for next iteration, do not add this value into this. So initially if you are having 100,000 values, from this 1000 in first sample, that is S1, we selected first 50 samples. When we want to go for second sample, that is when we want to choose second sample, we can get 50 records only from 950 because we are not replacing. This is called without replacement. Once an object is selected, it is removed from the population. It may not be considered. If you want to add it again, then we can go for sampling with replacement. A selected object, it is not removed from the population. That means every time from 1000 records, we want to select 50 sample as S1. In second iteration also, we will get the 50 for the sample 2 because again in 1000. Because after using this 50 records, again we are keeping it in its original data set. So even though if we repeat this process for 10 times, that is 10 sampling approach, total data size may not differ. That means in all the 10 samples, size of the data will be same. That is sampling with replacement. And the fourth one is a stratified sampling. Stratified sampling. So in this stratified sampling, we are going to partition the data set and draw the samples from each partition. That means, let's see this with small example. So in stratified sampling, let us assume this is our original data set. We partition the data set into 3 smaller parts. That is partition 1, partition 2 and partition 3. When we want to select a sample, try to select all the values from each partition, like select one sample portion here, make it this sample, and one more sample from here, and one more sample from here. So this is our sample data set. That is the meaning. This is original data set. Original data set has been partitioned into 3 partitions. From every partition, we are picking small amount of data. So here, when we partition the data set and draw the samples from each partition, that is proportionately. We are not saying we have to pick equal number of values. We are giving reference to all the partitions based on its count. Now, that is approximately the same percentage of the data. So let us assume we want to pick 10% from each data. So in this partition, let us assume we are having 1000 records. Here we are having some 1000 records. In third partition, we are having only 500 records. When you want to pick the approximately 10% from each and every partition, here if you took the 10%, you will have 100 values. Plus in second also 100 values. Next is also we will have 50 values. Totally we are having 250 size sample has been selected from all the 3 partitions. This is called stratified sampling. That means we are dividing the data into partitions. From each and every partition, we are making each and every possible value to be participated in the sampling approach. That is based on the approximate percentage of the data. And it is mostly used in conjunction with the skewed data. That means when we want to refine the data, when you want to use the data for analysis, we can go for the skewedness of the data can be increased here. Now, this is the diagrammatic representation of sampling, what we discussed now. If you look at that colored approach, simple random sampling without replacement. So here we select the 3 different colors. That means here we brought this sample item to here, and this also have been used here. That means all the 3 unique colors. This is, let us say, if we give this color number like 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. We are having 10 samples, and 10 samples we took only the 3 unique values. Let us say this is value 1, here we selected, this is 9th one, and this is some 5th one we selected. When comes to with replacement, a value can be used and again it can be replaced here. Let us say it was repeated here. Sample 1 is repeated here. This is 7th one. Here there is a repetition of the value. So in replacement, same value can be repeated. In without replacement, every time new value is going to be selected. Now, when we form the clustering or stratified sampling, this will be like this. Let us see here. Here the data has been divided into 3 partitions. Let us say this is partition 1, partition 2 and partition 3. And we are picking sample from each partition. Like, so the partition reflects the same here. This is P1, P2 and P3. From P1 we pick nearly 5 elements. Let us say. So these are the, from this set of P1 we picked only 5 elements here. And here when from P2 again we picked some 4 elements. So it is P2. From P2 here we got 4 elements. From P3, so it is nearly 9 elements are there. From 9 elements we picked 4 elements here. That means initially we divided the data into partitions. From each and every partition we are trying to get the data. Now this is data cube aggregation. So till now we have seen dimensionality reduction and numerosity reduction. And next one is approach of under dimensionality reduction is data cube aggregation. That means when we formed a multi-dimensional data model, technically we can call it as a cube. That is a cube structured data. Let us assume it's a cube structured data. So like this we can go for n-dimensional manner. It is a 3-dimensional cube. We can go for up to n-dimensional cube representation. The lowest level of data cube, that is base cube, and let us say it's a here we are deriving a lattice structure for all possible values. So this is called as a base cuboid. And this we can call it as apex cuboid. Okay. So it depends on how you are viewing. If you are drawing from top to down approach, the apex and base value will change. And if you are using bottom approach, the values will change. So whatever methodology you are using, we have to focus on what is the starting value and what is the number of dimensions you are using at the base level. So here, the aggregate data for a customer in a phone calling data warehouse. So here, when we are making or when we are picking a customer data information, we can pick it randomly. Multiple levels of aggregations in a data cube. That means we can apply all possible cube operations like OLAP operations on data to reduce the size. Like means we can go for a slicing of the cube, like we can select upper portion as a slicing, or we can rotate the cube, or we can go for the pivot of the cube. Slicing of the data, or we can go for dice of the data. So here we can apply OLAP operations, or you can say multi-dimensional cube operations to get or to collect reduced format of the data. So under data compression approach, here another dimensionality reduction approach is data compression. That means how can we compress the data. So in this we are having various compression techniques based on the type of the data. When we are having textual content or most textual content data, we can go for a string compression approach. There are extensive theories and well-tuned algorithms are there to reduce the textual content. And generally, most of the techniques are lossless textual compression techniques, but only manipulation is possible without expanding the data. When we are having multimedia data, we can go for audio and video compression. So typically, these are the lossy compressions. That means when we compress the data, either in audio or video data, if we go for a compression, the quality may be compromised. That means there may be chance of having lossy compression of the data. With progressive refinement, we can again retrieve the original quality of the data. Sometimes small fragments of signal can be reconstructed without reconstructing the whole. That means only sample data is going to be used for analytical activity. And time sequence is not an adequate. That means typically when there is no timeline in the audio, whatever we have taken for analysis, will take short and very slow with the time, and that is going to be taken for the analysis. So dimensionality reduction, numerosity reduction may also be considered as a form of data compression techniques. So in this data compression, we can see textual compression as well as audio video compression. Now look at here, when we are using a compression approach, so this is the original data. On this original data, we are applying some compression techniques. Let us say here we are applying some compression techniques. Again, after decompress the data, there may be chance of having some lossy. So when we are applying compression and decompression,
there is a possibility of having lossless compression and lossy compression. So generally all text compression techniques will have lossless compressions. When it comes to audio video, there is a chance of having lossy compression. So this is the way of compressing the data with lossy and lossless. It depends on the type of the data, how best we can view and how best we can derive. And when we move to the fourth data pre-processing approach, this is data transformation and data discretization. So till now we have seen data cleaning approach, data integration approach and dimensionality reduction, or you can say data reduction techniques. Cleaning, integration and reduction. Now we are going to see how can we convert the format of the data and how can we represent the data in another format, you can say encoded techniques, and how can we derive the discretizedness or hierarchiness of the data. Those concepts we'll see now. Now data transformation. Now what are the data transformation and why we have to use data transformation? A function that maps the entire set of values of a given attribute to a new set of replacement values. So what is the meaning of this maps that entire set of values with a new set of values? Let's take one small example. Here we want to replace the gender values. Let us assume we are having gender values like this. We are having gender values like male, female and transgender. We want to replace these values with another format of data. Like here we are replacing values like male with 1, male with 0, female with 1, trans with 2. Choice is yours. Or we can go for reverse. Alternatively, we can go for 2, 1, 0. All are accepted. Now what here we are trying to do? When we are replacing male with 0, that means every value is mapped with the new value. If you want to replace male with 2, we can do it. But what we are doing? Every value in this set is going to be mapped with every value in this new set. That is called transformation. A function that maps entire set of values of a given attribute to a new set of replacement values. That is, each old value can be identified with a new value. So this is way of replacing a gender value. Let us assume we are having an attribute, there is a possibility of more than 10 or 12 variables. That means 10 or 12 values. In that case also we can go this one. So it depends on our interest and requirement, which technique that we can adopt and that we can use for transformation. So here under data transformation, data smoothing we can apply. That means this data smoothing already we have seen in data cleaning. That means using binning approach, we can remove the noise from the data. And we can also apply data attribute construction or feature construction. That means new attributes constructed from the given ones. Or we can apply the required or the best aggregation approach to form the summarization of the data, to construct data cubes, or we can go for a data normalization. Under data transformation, we can apply some normalization techniques. That means we can scale the data which will fall into a smaller and precise range. Let us see this one. There is a attribute called the salary attribute. Here we are having some list of values like this. They may not in sorted order, but we are having some list of values like this. Now we want to convert these numerical values into a smaller range. Let us see here let us fix this 10,000 is the minimum here and maximum is 1,50,000. Now what is the range here? Here range is 10k to 150k. This is the range in the original salary. Now if you look at the range is little bit higher. Now we want to reduce this range and we want to represent it in another format. Why don't you replace this range between 0 to 1? Range between 0 to 1. How can we brought this entire values into a range of 0 to 1? Initially the range is 10k to 150k. Now we want to bring new values into the range of 0 to 1. How can we bring? How can we make and how can we convert the range from original salary to new range between 0 to 1? So for that we can use these approaches. We can go for a min-max approach, Z-score approach, normalization by decimal scaling. Those techniques we'll see. Now first we'll see what is a normalization approach here. So in normalization approach, when we want to apply min-max normalization, there is a formula. Here in min-max normalization, we are having old range of values. So in this previous example, the old salaries values range is 10k to 150k and we want to bring the range into 0 to 1. So here, when we want to apply min-max normalization, what is a new minimum range and new maximum range we want to bring the values. Now look at the formula here. So here the formula is V minus minimum A divided by maximum A minus minimum A. Now what is A here? A is the original data set. From the data set, take the minimum value, take the maximum value and which value we want to convert, that we can call it as a V, is multiplied with new maximum minus new minimum plus new minimum. Let us solve this with a small example here. Let us assume the income range of employees is in between $12,000 to $98,000 and we want to normalize this range 12,000 to 98,000 into the range 0.0 to 1.0. This is the original range of values and we want to create this new range of values. And here we want to convert this unique value. That means $73,000 value we want to convert and we want to fit in this range. Let us substitute the values. Here we want to convert this $73,000. This will become V here. And here minimum A, minimum, maximum A means original set. Minimum value is 12,000. This is minimum. 98,000 is the maximum. So now again it is minimum here. And here new maximum. So new maximum is 1.0. New minimum is 0.0. New minimum is 0. If we substitute all the values, we got a transformed value which is 0.716. 0.716. Now what is the 0.76? $73,000 value has been converted into a new value called 0.716. So 0.716 is the new value. Like this, in this range, any value can be replaced with a new range between 0.0 to 1.0. And second one, or the second approach is Z-score normalization. In Z-score normalization, we can use this formula, that is V dash is the newly obtained value, V is the value that you want to convert, mu is the average or the mean of the original data set, sigma A is the standard deviation of the data set.
So if you want to convert the values into Z-score normalization, initially we have to calculate the mean value, that is average value, and standard deviation of the data set. Let us assume the previous example, that is values between $12,000 to $98,000. Their mean is 54,000 and the standard deviation is 16,000. That means these are the pre-calculated values. Substitute the values. Here we want to convert 73,600 and the data set mean value is 54,000 and standard deviation is 16,000. If you substitute, we got 1.225. That means in Z-score normalization, $73,000 value is converted into 1.225. So in min-max normalization, for the range 0 to 1.0, we got 0.716. In Z-score normalization, we got 1.225. So whichever is feasible for our application, we can use that normalization. And the third approach is normalization by decimal scaling. That means here we are converting only its format, not the value. That means here we are dividing the value, each value with 10 to the power of required number. Let us assume if you want to convert with a 3 decimal space, j value can be 3. That is, divide every value with 10 cube, you will get modified value. This is the meaning. Okay. So till now we have seen the normalization techniques. Now next one is the discretization. That means how can we format and how can we represent the data. So when we are dealing about the types of attributes, basically there are 3 types of attributes. They are nominal, ordinal and numeric. Values from an unordered set, we can call it as a nominal, like color, profession. Under color, we may have a set of values like we may have red, blue, green, yellow. It depends on our request. And when it comes to profession, let us say maybe lecturer, assistant professor, associate professor. Like that, we will have various designations. So like the values from an unordered set, there is no order at all and there is no restriction for number of values. When it comes to ordinal, values should be in order. Values should be in order. Like when we are giving a rating to a product, the value can be between scale 1 to 10 or 10 to 1, but not in random order. And third one is a numeric. Numbers and real numbers are integers. We can call it as a numeric. Now what is a discreditation here? Here we are going to divide the range of continuous attributes into intervals. We want to divide the range of continuous attributes into intervals. Let us assume we are having salary 10,000 to 1,50,000 is the highest value. So there is a continuity in this. Instead of taking the entire range, let us divide into smaller subsets like 10k to 20k one group, 21k to 40 another group. Like this we can smaller subdivide. That is the meaning here. Divide the range of continuous attributes into intervals. Now interval labels can be used to replace the actual data values. Like this group can be taken as group 1 and second group can be taken as group 2. Instead of using that value, you can use G1, G2 in the place of this value range. Now what is an advantage here? It will reduce the data size by data discretization. We can go for either supervised or unsupervised approach to form the data. Now what is supervised, unsupervised, we will see in later slides. And we can split the data and we can merge the data. When we are splitting, we will apply top-down approach. When we are merging, we will go for bottom-up approach. Now discretiation can be performed recursively on any attribute. Let us see this example here. Now in this discretiation method, we can go for histogram analysis, clustering analysis and decision tree analysis here. Just observe here, in this
discreditation without using class labels, binning versus clustering. Now here we divided the data into binning in these first two diagrams, whereas in these two diagrams we applied k-means clustering. So both methods are intention is we want to group the data, but it differs. The number of elements which are going to be formed in every group will differs here. Now when it comes to discretiation by classification and correlation analysis. So here the correlation analysis already we have seen in chi-square analysis in the previous example here. Now when it comes to a particular attribute, like so when it comes to nominal data, here we are dividing data based on a request. Like here when we are representing the address, the residential address, we can divide like street, city, state and hierarchy, country. That means in hierarchical approach we can represent the data. The specification of hierarchy for a set of values is explicit data grouping. Now it depends on the requirement how best we can use this hierarchy. Now hierarchy related to this example here. If you look at carefully here the values have been grouped. Here we are having 15 distinct values for country, 365 distinct values for province or state, like 3561 values for the city, and street values are like this. That means if you look at carefully, the count is going to be increased and all the values have been grouped in a hierarchical representation. So this is the way of reorganizing the data based on our requirement. Even the time also can be represented like weekday, month, quarter, year. So till now we have seen various data pre-processing approaches. The next class we'll see what is data object, types of data objects, and we'll see some statistical measurements approaches which are going to be used in data pre-processing. Thank you.